Okay, these are the 6.2 notes over arithmetic sequences and series. So, an arithmetic sequence is a sequence in which the difference between successive terms is a constant. The constant is referred to as the common difference, which we will denote as D. So, what that means is if the difference between successive terms is a constant, that means it's the same difference from here to here as it is from here to here. They're all increasing or decreasing by the same number. That is the definition of an arithmetic sequence. If you have one that first it goes up by 2, then it goes up by 4, then it goes back to 2, or anything like that, it is not an arithmetic sequence. An arithmetic sequence, it goes either up or down by the same number every time. The common difference is that number. So let's figure out what the common difference is. And the easiest way to do this is just subtract two of the terms. So I always like to do the second term minus the first term. So 12 minus 17, which would give me negative 5. So the common difference for this first sequence is negative 5. So if I want to find the next 4 terms of this arithmetic sequence, I'm just going to keep subtracting 5. So after 7, if I subtract 5, it would be 2. Then if I subtract 5, it would be negative 3. Then if I subtract another 5, that's negative 8. Subtract another 5, that's negative 13, right? Yeah. And that's all we needed, was to get 4 terms. Okay, number 2, let's find the common difference. So again, I'm going to subtract the second term minus the first term. So 187 minus 244, which is going to give me a negative 57, meaning it's going down by 57 every time. So if I were going to write the next 4 terms of the sequence, I would do 130 minus 57, which would be 73, minus another 57, gets me down to 16, minus another 57, negative 41, minus another 57, negative 98. Cool. Okay, because each term in an arithmetic sequence is found by adding the common difference to the previous term, the recursive formula, a of n equals a sub n minus 1 plus d, can be used. This formula can be used, that's a typo, can be used to write an explicit formula, a sub n equals a sub 1 plus d n minus 1. This is the formula I'm going to use the most because just in general, explicit formulas are easier than recursive formulas because if you remember from 6.1, when we do a recursive formula, that's when we have to do every single number to get where we want to go. Whereas with an explicit formula, I just plug in the one that I want. So, let's see if we can, we have to do both on this one though. Okay, we got to write a recursive formula and an explicit formula for the nth term of the arithmetic sequence. So, number 3, our pattern is 12, 21, 30, etc., etc. So let's start with this recursive formula. A sub n, well that's part of my formula. A sub n equals a sub n minus 1. And then we need to know what d is. Remember, that's our common difference. That's what we were doing on number 1 and 2. So we're going to subtract 21 minus 12, which would be 9. So, yeah. So that would be our recursive formula. And remember, for a recursive formula, we need to define our first term, where a sub 1, meaning our first term, is 12. That would be how we rewrite the recursive formula, this one right here. All right, let's do the explicit formula. So to find a sub n, we start with a sub 1, which is our first term, which in this case is 12, plus, our common difference, which we found was 9, times n. N n is whatever term we're looking for, right? So I don't know what to plug in because I want a formula for n minus 1. And then I'm just going to do some distributing. Oh my gosh, spin. 12 plus 9n minus 9. Combine some like terms to end up with 3 plus 9n. And that would be an explicit formula for number 3. Let's do that same process for number 4. Let's start by finding our common difference. So we're going to subtract 23 minus 35 to get negative 12. So if I want a recursive formula, a sub n equals a sub n minus 1 minus 12. Where, because remember with recursive, we have to define our first term. A sub 1 equals 35. Okay, now let's get our explicit formula, this one right here. A sub n equals a sub 1, that's our first term, that's 35, plus d, which was negative 12, so I guess I could have written minus, but I'll clean it up here in a second, n minus 1. Okay, let's simplify this just a little bit. Let's distribute that 12, 35 minus 12n plus 12. Combine like terms, 47 minus 12n. That would be our explicit formula for finding a sub n. Okay, number 5. So our directions say, find the specified term of the given sequence. So I'm going to go through the same process because I don't really want to count all the way out to the 68th term. We don't have time for that. So instead of doing that, we're going to come up with one of these formulas like we did here on 3 and 4, and then we're going to use that formula. Let's do an explicit formula, because like I said before, with a recursive formula, we'd still have to count all the way up there. With the explicit formula, we can jump right to the one that we want. So let's find an explicit formula. So let's find d first. So d would be 17 minus 25, which would be negative 8, right? Negative 7. Yeah. Is that right? That's 8. Negative 8. Okay. Yeah, so we've got our common difference, and so now let's find our explicit formula. So a sub n equals a sub 1, which is our first term, which was 25. 25 minus 8 times n minus 1. That would be our explicit formula. We could go ahead and simplify, but you know what? The point of this is not to find the formula. I just need to find the 68th term. So I'm going to use this formula. I'm going to go ahead and plug in 68. So 25 minus 8 times 68 minus 1 would be 25 minus 8 times 67. Gross. Let me pull up a calculator. Give me a sec. Okay, I've got my calculator pulled up. I'm just going to let it help me with some of these larger calculations. So what I needed to do was 67 times 8, which would be 536, which means now we've got 25 minus 536. What is that? 25 minus 536 is negative 511. which would be our answer. That's our 68th term of that sequence. Aren't you glad we didn't count all the way to it? Okay, number 6, find the 39th term. Again, I really don't want to do that 39 times, so I'm going to find the formula once and then just plug in 39. So first let's get our common difference. So D equals 10 minus 4, which is 6, so these are going up by 6 every time. And then let's get our formula. A sub n equals our first term, which is 4, plus 6 times n minus 1. And again, we can simplify, or let's just go ahead and plug it in. Let's plug in 39. So a sub 39, or the value of our 39th term, is 4 plus 6, 39 minus 1, 4 plus 6 times 38. I'm going to use my calculator for that. 6 times 38 is 228. Which would be 232, which is our answer. Okay, let's flip it to the back, maybe. Okay, so we dealt with sequences where, they go either up or down by the same number every time. Now we're going to deal with a series. An arithmetic series is the indicated sum of the terms of the sequence. So basically the sequence is just the list of numbers. The series is when you add that list up. So it gives us this formula. To find the arithmetic series, here's this formula. So the sum of those numbers is equal to n, where n is the number of terms. The number of terms. A sub 1, well, we've seen that before. That's our first term. And a sub n is our last term. So let's see if we can find the sum of these series. So let's plug things in. To get the sum, we need the number of terms. Well, let's see, we have 1, 2, 3, 4, 5, 6. 6 divided by 2. And then a sub 1 is our first term, that's 12. A sub n is our last term, which is 42. And now I just got to do some algebra. Let's see, 6 divided by 2 is 3. 12 plus 42. Let's go ahead and add those numbers. That's going to be 54. And if I multiply that, that's what? 162? Yeah. Cool. 162 is our answer. Now, another way we could have gotten this, we could have just added these numbers up. But the reason we did it this way is because I want to prepare you for these next questions, because it's going to be a lot harder to just add them up. Because like if I look at number 8, well, here's the problem. There's an ellipses here in the middle, meaning there's a lot of numbers in there, and I don't necessarily know how many numbers there are. So we've got a lot of stuff to figure out before we can start plugging things into our formula. Like I need to know how many terms there are, right? I mean, it shows me 4 of them, but I know that there's a lot more between 9 and 317. So the way I'm going to do this is I'm going to use the formula that we used on the front page. The one that was, let me write it different color. The one that was the one for finding a given term. A sub n equals a sub 1 plus d n minus 1. I'm going to use this formula again. And so to use this formula, I know n is what I'm looking for. I got to know what d is. That's our common difference, remember? So that should be easy to find. That's just our second term minus our first term. So 2 minus negative 5, which would be 7. So this is going up 7 every time. All right, we can do that. So let's see if we can use this to find what n is. So we're going to plug things into this formula right here. A sub n, that's our last term. 317 equals a sub 1, that's our first term, that's negative 5, plus d, we just figured out that's 7, of n minus 1. Okay, cool. This is an algebra problem. Let's solve for n. I want to get n by itself. First thing I'm going to do is add 5 to both sides. Plus 5, so that's 322 equals 7, n minus 1. Divide by 7, divide by 7. I don't know what that is. 322 divided by 7. It's 46. 46 equals n minus 1. Add 1. N is 47. Cool. Now I am ready to put this into my sum formula. This one right here. Right? Where the sum of all these numbers is the number of numbers n. That's what we just figured out, right? We had 47 numbers over 2. And then in parentheses, the first term plus the last term. The first term is -5. The last term is 317. And then let's simplify. 47 over 2. -5 plus 317, that would be 312. And you know what, let's just use our calculator for this. 47 over 2 times 312. 7,332. That is our answer. A lot of times when you do these problems, you're going to have really big answers, which makes sense, right? Because I'm adding up every single number, and there's several in the 200s and the 100s and the 300s. It's going to be a big number. For the summation ones, for the sum, for the series ones, that's okay. That makes sense because remember what this means is I'm adding them all up. So if you add up all 47 of those numbers, you're going to get a really big number. Okay, last one, same kind of idea. It doesn't tell us how many numbers we've got. We're going to have to figure it out. So let's get our common difference first by doing the second term minus the first term, 193, minus 211. That would be -18. Is that right? Let me double check. 193 minus 211, 11, -18. Cool. And this will be a calculator test, by the way, so don't be stressing about that right now. -18. Okay, cool. A sub n equals a sub 1 plus d n minus 1. Right? That's that formula we learned on the first page. So a sub n, remember that's our very last term. -455 equals a sub 1, that's our first term. 211 plus d, we just figured out that's -18. N minus 1. Okay, let's solve for n. Let's subtract 211 on both sides. So -666 equals -18, n minus 1. Divide by -18, divide by -18. I don't know what that is. Let's find out. -666 divided, oh my gosh, divided by -18 would be 37, which means n is 38. Okay, now we're ready for our words keep leaving me. Our series formula, the one where we have to add them all up. So the sum of all those numbers is n, which is 38, over 2, and then in parentheses the first term, 211, plus -455. So that's what, 19? Yeah. 211 plus -455, that's going to be -244. And if I multiply those, 19, that's what it was, right? Yeah. 19 times -244. Oh no, 19 times -244. negative 4,636, which would be our answer. Yeah, this stuff isn't easy, I know that, but you can do this. Just keep your notes out, look at those examples, look at those formulas, keep them in front of you. Ask questions when you got them. You know we're here for you. You got this. Good luck.